So now we are entering into the next layer, right? So far we discussed about these 5 layers like data engineering, machine learning, sorry, data science, machine learning, and deep learning. Now let's see. Let me do a quick refresh. Okay. So now you understand through an example, ShopSpear, an online retail firm, what sort of data that they collect, like clickstream data, sale orders data, reviews, images, and so on, right? And what is the role of data engineering, like Kafka, Apache, Daxter, like streaming data, and also how to organize either through a data warehouse, a lake house, etc. Right? Then the data science part, identify the business problems and come up with a hypothesis, do the testing, help them to make a decision. So then the machine learning part, if there is any statement or hypothesis came out as a positive for business to further to grow or know more about any uncertain situation, then machine learning comes in. Could be a classification or a regression. Right? So we discussed what are the ways how a model work, and you have seen examples as well. Then the deep learning part. So wherever the data is massive data or any unstructured data where machine learning cannot build the relationship, then you bring deep learning, especially for the sequence data or for the images or for the sequence text, right? So we discussed deep learning examples as well. So you have gone through machine learning examples and then deep learning examples. I hope you, by the time you execute on your own the examples that we discussed, so you will be more comfortable. Okay. So now, so this is the flow actually. This is the journey, right? So next layer is what? The natural language processing. So very powerful. And this is the, I would say, key for your agentic AI, right? So if you understand NLP well, then you understand agentic AI very well. Because, right, what is agentic AI? You actually you build an agent, you give a prompt, right? Or you build something how your mind actually thinks. The agent also learn in similar way and try to make actions and work towards a goal. Let's say to come up with a machine learning model which gives accuracy and immediately build another machine learning model if there is a drift, etc. So to set those rules and all, your agent should know the language also, right? So the what the prompt that you are actually giving, if it is a prompt based. So please focus from here. This is very, very important. NLP, natural language processing, because everything is text now, right now, right? So prompt is a text. And the customer reviews, in our example, customer reviews, you name it. So we'll learn what are the different use cases or different methods available in NLP, what sort of use cases those methods will really help. All right. So now, why this is genuinely hard? Language is genuinely hard. So, maybe language looks simple, right? But we use every day. But for machines, language is very difficult. Suppose if I say that, I never said she stole my money, right? So 7 words, but depending on, which word you stress, the meaning changes. I never said she stole my money, or I never said something like that, right? So humans, we, given our experience since childhood, we will listen and we react. So that's easy for us. But for machine, so it is difficult to understand and extract the relationship and what is the context, etc. Right? I never said means maybe someone else said. I never said she stole means maybe I only implied it. I never said she stole my money means maybe she took something else, right? So this is why language is very hard. So there is ambiguity. For example, I saw the man with the telescope who had the telescope. So me or the man. So there is a sarcasm. I saw the man with the telescope who had the telescope. Sarcasm. So if someone says that great, another Monday, the word great is positive, but meaning may be negative. Usually, Monday morning when we log in, great, another Monday. It's a sarcasm, right? The context, maybe as a human, if you see the face of the other human who is saying these words, you can understand the context and you get the sense. What is the, the context that this person is about, right? But wherein for machine, it is not easy to understand. Right? For example, the word, if I say bank, right? So here the context dependence, the bank. So bank means a river bank also a bank, right? And financial bank is also a bank. A financial institute is also a bank. So there is a infinite variety. There is a lot of difference between this bank and this bank. But how machine or human can understand based on the complete sentence or maybe the slang, a short form. All right. So this you have to be discussed about ambiguity. Then the sarcasm example I've discussed. Context is very important. If you just say bank, you may think that river bank or a financial institution. So you have to make sure that the surrounding words are more meaningful, right? So then the last one is right, infinite variety. So we have slangs, we have typos, abbreviations, right? A lot of times what we do, we mix Hindi in India, right? Product अच्छा है, but delivery बहुत late है. So what does it mean, right? So product अच्छा है, but delivery बहुत late है means the product is good, but delivery is too late. So you're mixing up things here, right? That's actually a mixed language. So NLP systems must still understand the meaning. So here, if anyone is really interested to do research, okay, text is the space you have anonymous, like, or I could say like exponential growth, phenomenal growth, or I mean, n number of opportunities. So you start researching about text, you get to see still so many problems unsolved, right? So far we are good, like 50-60%. We extract the themes and get insights that meaningful, but still there is a lot to research and advance the text-based analytics, right? So that's about NLP. That's why always remember NLP is a directional. It is not 100% accurate, right? So you have to tune, you have to add more and more training data to make sure your NLP insight is meaningful. Okay. So the classic NLP pipeline. So before modern AI, like Transformers is the latest one, right? Before AI and Transformers, NLP used to use a step-by-step pipeline, right? So of course, still for few algorithms today also we follow the same pipeline. Okay, let's understand this simply, right? Suppose Shopspeare in our example, right? So if one user posted a review, so Shopspeare gets a review. We're saying that, okay, the shoes are running small and delivery was very late. So the shoes, let me write it here. I think here it is there. The shoes are running small and let's say the delivery was very late. This is a simple line. So the first step is tokenization. So what is tokenization? You are breaking the sentence into smaller pieces. The shoes are running small and delivery was very late, right? So you have to tokenize. I mean, when I say you, the machine, once you want to process it, the first step is you tokenize the sentence. Then remove the stop words. So what is the meaning of removing stop words? The, is, are, a. So these are actually stop words. The reason that, if you have more and more stop words, they may not add much meaning in some traditional models. So they are removed. Then stemming or lemmatization. So what is the stemming and lemmatization? So reduce the words to the base form. For example, if I say running, so it will convert this into run. If I say eating, it will convert it into eat. Suppose if it say runs, simply says run, or it says ran, it's also run. So this is called stemming. You are actually reducing the words to their base form. In English, you have the base, right? And past tense, present tense, like that. So you get it to the base. Then the next one is vectorization. So what is vectorization? Because machines cannot understand words directly, right? So they need numbers. So text is converted into numbers using models like there are models. Okay, I'll show you when I run the hands-on example, right? It's called bag of words. This is one method. Okay, and term frequency and inverse DEF, IDF. I think inverse. Sorry, I forgot, but I'll discuss when we do worked out example. Frequency. So TF, IDF is one method. Bag of words is one method. So these methods are used to convert your text, stem text or lemmatized text into vectors, right? So vectorized. All right. So then the model receives this numeric input and predicts. Suppose if you want to classify, there is a text classification also algorithm, right? So once you do all these steps, right? So tokenization, removing the stop words, lemmatization, vectorization, this vector gets into the model input to predict whether it is a positive review or a negative review. Is it about a delivery or a product or a quality or refund, whatever classification if you want, you can actually do that. This is the classic NLP pipeline. This was very useful, but it had its own limitations. Okay, it could count words, but it not deeply understand the meaning. Based on the frequency, it will generate the vectors. So that vector you use to get, you know, go and do proper search through a master database or vector database, do whether it is a sentiment extraction, semantic meaning. I'll discuss all the use cases in detail, don't worry. But at a high level, this is the traditional NLP pipeline, right? So tokenization, removing stop words and stemming, and then vectorization model input. Okay. Now, so counting words and how. So we discussed previously, we discussed the process, the pipeline, right? So removing the stop words, stemming, and then vectorization. Then it counts the word using the methods. So now how the counting words to understand how machine will understand this one, right? So there are few models. This is where actually I could say the major evolution in NLP around 2014, 2013, right? Where is my this one? Word to vec. So word to vector, right? So earlier models counted only words. Okay, if the word, let's say, bad appeared in the model in the text, right? The model just classify it as a negative, irrespective of the context, right? You understand? Suppose if I say the simple, right, the delivery was bad, but the product quality is amazing. So technically, the customer is positive, right? So, but given the bad word is there, it simply classifies into negative, right? So that's actually where we got this word to vec. Word to vec helped machines understand relationship between words. So how it actually gets the relationship between words, again based on the semantic vector. So basically, there is a vector database saying that, okay, for this word and this word, this is the meaning. Again, in vector form, numeric form. Okay. Suppose if I give a simple example, let's say king is related to queen, man is related to woman, right? Let's say if I give another example, right? Paris. So Paris is related to France, a country, right? So this was a big breakthrough happened in NLP because words started getting meaning through numbers. So word to vector. So using the vector, it go and search in the master vector database, then it extracts the meaning. Okay. So, but again, word to vec also has one limitation, right? So the same example, right? The word bank had same vector, whether we say I deposited my money in the bank or I sat near the river bank, right? So same thing. Then it comes this context thing, bird. Okay, so this was developed by Google. So BERT is a method or algorithm or a transformer based, the basic transformer based algorithm introduced a contextual understanding, the context. So if I say that, okay, just give me this one, right? The one example I just mentioned, right? The bank. I deposited money in the bank, right? I sat near river bank. So machine may think that bank is a bank, financial institute, whatever Definition, it is there in the vector database. It actually extracts and it assigns and it classifies. But that is, these two are not same, right? So bird brings the context. Okay. So how the context? Simply based on the surrounding words. So here, if you see, I went to bank to fish. Fish means something in the water. So definitely the context is getting more clarity to define what is bank here is. I went to the bank to deposit. So related to money. So the word bank, now he got context, right? So this is closer to how humans understand the language. This is the journey. So first computers counted the words, then they learned word meaning, then they learned meaning based on the context. Okay, so that is the NLP. Now, I mean, I'll explain the process, like, how to run this BERT algorithm and all. Okay, don't worry. In the workload example, first I'll cover the theory, then we'll go on to the practice NLP part. Okay. Now, core NLP tasks, right? Practically, you may think like, okay, now I understand there is a huge text. You're saying that, there is a method, there are methods which tells me the meaning of the words, the text. Okay, but what are the different real-time use cases, right? What is the business, really business wants to use this text? That's why I mentioned a few minutes back. NLP is a really amazing space if you want to do more research. So the first task is classification and sentiment. So whatever text you have, reviews, okay? Sometimes, there is a call between customer care executive and the customer. So that call also can be converted into text and can be applied any of the method to classify whether the call was positive or negative. The customer tone was positive or negative, right? So this is one of the best example in NLP, one of the most important, I could say, use case. Okay, you are categorizing the text. For example, the customer care executive, at the same time sentiment, movie reviews in book my show, okay, in Twitter tweets, everything, whatever review you see as a positive or a negative or a neutral, manually is not possible to process millions of reviews, so you can apply NLP. It can also classify uh, the issue, delivery issue. Suppose if there is a delivery issue comment given by the customer, or a damaged product, or a payment issue, technical issue, refund issue, anything, right? That is one, classification and sentiment. The next one is named entity recognition. So you have huge text here, right? So in this text, apart from the classification and sentiment, whether it is a positive conversation or a negative conversation, I need to understand if this text has any event or places or organization or any date, etc. Why? So that I can extract that information and I can use it for my analytics purpose. Suppose if I say that I have my Apple phone, okay, my Apple phone order placed on 10th May, right, is delayed. So you identified the comment saying that there is a delay, the customer is not happy. But to extract if there is any issue, it's not easy to go through millions of texts, right? So this tells, okay, there is there is an Apple phone ordered on 10th May is delayed. You can quickly go back and check, right? So that is named entity recognition. So it will help you. There is a method in NLP, NER. So it helps you to extract the places, names, people names, or any city name, or brand names, etc. It extracts from the unstructured text. Okay. And then the next one is the third task is summarization and translation. So what is this summarization? I have a 1,000-page document, right? So for me, I don't have time. I have only 10 minutes time. I just have to go through this 1,000 pages and get some highlights, right? One, two, three highlights, a summary kind of thing. Okay, or a translation. Translation is language to language translation or a summary. So there is a long customer complaint. So from 10,000 words are there, right? Or 5,000 words are there. So it takes a lot of time. And this 10,000 words, let's imagine there is a language Hindi. This is not in English. So you have to translate this to English and pass this English comment to your model to understand what is the issue, what is the summary of the big complaint, right? Similarly, if you apply this concept to the reviews, journals, etc., if you have a 10,000 pages document, you don't have time, you can actually ask the machine to review and summarize for you. So you get a cursory of the entire document, right? So that is about summarization and translation. The last one is question answering. So you have 100-page document. You made your machine, your NLP model to run, to learn the entire text, whatever text you have, right? Then it keeps everything in its memory. Then if you put a question, it will go and search the respective answer from this text and give the answer to back to you. Okay. So, for example, if I say, hey, what is the written policy for shoes? The algorithm, it searches the policy document and give the correct answer, right? So that is question answering. So these are all, kind of fundamentals, or I would say foundational algorithms or use cases for your GenAI and agentic AI stuff. If you understand this core NLP through our practical examples that we will be discussing soon, you will easily understand GenAI and agentic AI, right? So these four tasks power many real-world systems like search engine, automation, support automation and review analysis, compliance systems in banking and different pharma. The compliance systems also, right? It's not possible for human to go through thousands of pages, right? So a knowledge assistance, these days, knowledge assistance, you prompt something, you get. This is the backend. Logic is NLP, right? So these are the broad area of use cases for our from our NLP thing, right? The next one is our example, Shopspeare, right? So NLP review, intelligence at Shopspeare. So we'll bring whatever we discussed in earlier slides to our Shopspeare example. So these guys receives thousands, right? I could say not only thousands, sometimes more than 1,000 in a day. So 1K plus reviews, right? Every day. Manually reading all of them is impossible, right? So NLP helps convert customer language into business intelligence, right? So for example, customer may write saying that delivery was too late or late. The delivery was late. So the size is smaller than expected. Packaging was damaged. The product looks different from the photo. What the photo actually was and what actually product is not the same. So NLP can automatically detect the topic and it detects the sentiment. If the customer is happy or disappointed or angry or neutral, anything it can extract. So the system can route the issue. So they will escalate it to the next level to make sure that the customer service experience is good, right? For example, it's a delivery complaints. They send all those to the logistics department. If it is a product quality complaints, they send all those to the seller management. If it is related to refund complaints, then it will route to customer support. So your AI NLP algorithms, they are reducing the manual effort and optimizing the customer service experience. So this is the best example. Very powerful because feedback is kind of, customer feedback is very, very important. You have to read and make sure you react so that your customer will retain with you, right? So that's about the NLP example on this one. Now, so before I wrap up this NLP topic, right? So let me introduce this GPT family, right? So the GPT versus BERT. BERT, a minute back we discussed when there was no context in NLP. The BERT is the first algorithm developed by Google, wherein it brings the context, right? So very, very important, guys. Please, people often hear BERT and GPT, but don't know the difference. So let's keep it simple. BERT is mainly used to understand the text. GPT is mainly used to generate the text. Simple, right? So BERT reads the full sentence from both the directions to get the complete sentence, or the, I could say, meaning, etc. Right? So it reads from the left to right and right to left and get the context, and it help you based on your need. Right? Sentiment analysis, classification, named entity recognition, semantic search, question answering thing, whatever we discussed. right? So if Shopsphere wants to classify customer reviews into delivery issue, product issue, compliance issue, sorry, refund issue, payment issue, BERT is very, very useful, all right? So the BERT is very, very useful. Wherein GPT, it works differently. So GPT predicts next word. Okay, so it predicts next word, technically the next token. So that is why GPT is excellent at writing or summarizing, answering, coding, and conversation, etc. So in ShopSpear, if you want to bring this right to generate a polite reply to a customer complaint saying that, hey, sorry for the delay, we will work on it and you will receive it as soon as possible, right? So just take this, take away from this slide is BERT is like a reader, okay, wherein GPT is like a writer. Simple. It writes, it creates the content, text. First, BERT understand the context and it reads, keep it with him, with it, and then respond based on the need, whether it is a classification or semantic search, etc. Wherein GPT generates new text, right? So companies often, use both technologies, or I could say frameworks, because both are very, very powerful algorithms or frameworks, right? So that's about BERT and GPT. Evaluating NLP is not always straightforward, right? In image classification, the answer may be simple. Is this a shoe or not? But in language, answer can be subjective, right? Suppose AI summarizes a customer complaint, right? One person may say that the summary is good. Another may say it missed the emotion, right? Another may say it is correct but not professional, right? Just you go and ask your friends, like same question, if you ask five people, same movie review, if you ask five people, you get five different responses. So that is why NLP evaluation is a bit tricky. So there are automatic metrics like Blue and Rog. When I say metrics, right, if you can go back and recall what we learned about our classification algorithm metrics, right? Accuracy, precision, ROC curve, all those things. Similarly, how do you justify that your NLP algorithm is accurate? You're accurately working or predicting or classifying, right? So Blue and Rogue are there, but again, these are not 100%, but it based on the compare. You have to compare the generated text with reference to some text. This only works if you have a text to compare and it will validate and it will confirm saying that, okay, my model is perfect. Okay, but to be honest, they're not 100% perfect. A model may score well, but still produce unmatured or unnatural outputs, right? So it's your call, right? You have to make sure you're evaluating how randomly take the outputs and evaluate takes some spend time until it learns well, right? So human rate for accuracy, I think here I mentioned, right? So correctness, helpfulness, clarity, it's actually it takes time, but now it's important, right? So that's why LLMs are placing now. LLM is right now is emerging as a judge. This a strong LLM evaluates the output based on a rubric, right? So this one example, right? If I say, was it polite? Was it accurate? Was it complete? But even here, human spot checking is important, right? The key message is language quality is not only about correctness, it is about the tone and the usefulness, okay, and the context. Please be mindful. Please be mindful when you are taking the insight from language-based models and how you are leveraging them to, make any decision for your business. That's why human intervention is very, very important to validate some insights before that. You will understand all those things what I'm actually speaking about, right? When we do practical exercise. But I hope you understand the theory part and NLP at a high level. Natural language, machine, will do a process, will follow a process to understand the text, clean it up, and try to get the sentiment or semantic meaning, right? If you pick bird, it will give the context, named entity recognition, etc. Right? And the transformers, the latest evaluation, the way how it is evolving is amazing. You can actually generate text, right? That is about NLP at a high level. So this is a simple example, right? So I mean, once you have these algorithms, you can actually uh, automate Shopspeare support tag. So there are like every day you get 10,000 support tickets, right? So support ticket in the sense, suppose if there is a issue, if there is a delivery issue or a refund issue, right? So you get more and more tickets. Without AI these days, human agents, people are preparing, agents to read each message and decide where it should go. It should go to a refund team, shipping or a product issue or account issue, right? So basically, this creates bit delay again after NLP, right? So customer has to wait for us. So what you have to do is you have to prioritize, flag urgent tickets. How do you get that urgent again? Based on the extreme sentiment, based on the extreme sentiment. So you prioritize and make sure that the urgent tickets got, we call as solved ASAP. Suppose, for example, say my order has not arrived. It's a shipping issue, right? But it's a broken item, product defect, right? So then you have to prioritize. So you go to classification, then prioritize. So then after prioritization, a high value customer with an angry complaint, may need a faster attention, right? So suppose if his tone is aggressive, right? Or if any legal or compliance related issue, you have to be immediate what do you call attention or escalation. Otherwise, it will impact your brand reputation, right? So the draft. So what is this draft? The systems generate a reply, right? You once you see the comment, immediately you put your agent or automatic AI, machine learning, sorry, the NLP based stuff. So it actually generate a automatic reply, right? A human agent can review it and send it. So AI is not replacing the support team completely, but it is helping, to make them work faster and better. That's it. Okay. In this example, hope you understand, right? A lot of people say that AI replace humans, or humans gets replaced by the AI. No, that is not possible. So you have to set the rules, the business rules, which kind of tickets are, high priority, extreme, urgency. Then you validate some samples to before you send the review. Otherwise, again, it's a complaint. It will be a compliance issue if machine puts some wrong words, right? There is a possibility, right? So you're reducing the time, you're reducing the manual effort, you're optimizing your customer service experience. So again, I'm telling you the examples what we do. We go through the word example, then you'll understand more. But NLP, make sure you understand the need, the context, what exactly the purpose of this, and bring the relevant method or algorithm and apply it. Then bring the insight. Okay, please, because when I ask question, what sort of Gen AI or NLP based exercise that you do, have you executed? If I ask the question when I was interviewing, right? Suddenly people start juggling. I build RAG systems. Okay, what is the purpose? RAG system. There is a simple question and answer thing is there for a simple basic time-based document. You need to build a RAG pipeline, right? It's unnecessary expensive for a generic, scenarios, not a, pharma or I would say banking related stuff. It's a small, simple thing. Movie reviews, for example, one person was saying last week. So why? I mean, it's a generic thing, right? GPTs easily understand why you're investing heavy pipelines and I mean like money and time. So please practice more and more on text-based algorithms, then only apply appropriate algorithm. Okay, let's move on to the practical exercise of the text-based stuff, NLP stuff, right?